Hey guys, today we're going to talk about solving polynomial equations. And so this is the worksheet that we're kind of working off of. The left-hand side is just like fill in the blank notes, and then the right-hand side is going to be what you'll be doing for homework. What I'm going to do is I'm going to go through examples 1, 2, and 3. So if you're at home and you want to print this off so that you can fill in the notes like that, then you can, or if you want to just write your own notes, then that's fine too. But I just wanted to give you a heads up that this is the sheet that we're working off of. So, starting at the beginning, we're talking about finding all of the zeros, real or imaginary, of polynomial equations. So basically, we're going to talk about cubic, quartic, and quintic, and that one is x to the fifth. You're not going to use that as much. But basically, if it's cubic, then there's going to be a total of 3 zeros or 3 roots. If it's quartic, there's a total of 4, and if it's quintic, there's a total of 5. So I did this a little bit backwards because I wanted to talk about the total number of roots or solutions that you're looking for first. And then I also want to talk about for cubic, that means that you have x to the third power. For quartic, that means you have x to the fourth power. And quintic is x to the fifth power. So basically, it's whatever the highest degree is in each of these. That's how many total solutions you'll be looking for. And then the first step is always going to be to graph it and find as many zeros on the graph as you possibly can. So just make a note to yourself that you're always going to graph first and find as many zeros as you can. So if it's cubic or x to the third, you have to find at least 1 zero on the graph, and I'm going to show you what that looks like in a minute. If it's quartic or x to the fourth, you have to find at least 2 zeros on the graph. And then if it's quintic, you have to find at least 3 on the graph. So just kind of like make notes of all of this real quick first, and then we're going to go through a few examples so you can see what I mean whenever I'm talking about like how many you're finding on the graph and also how you find the other two for each of these. Okay, so here's example 1, and like I said, I always want you to start by graphing. So I think I'm actually gonna graph these on Desmos, so let me get that pulled up real quick. So our equation for our first example is x cubed plus 2x squared minus 5x minus 6 equals 0, and we're looking for all of the solutions to that. So I went ahead and graphed that equation on Desmos, and we're looking for where it equals zeros, so that's going to be all of our zeros. So since it's x cubed, that means we're looking for 3 different zeros. And then if you look at this one, we kind of got lucky on this one because you can see all 3 zeros on the graph. So that means that the 3 solutions or zeros that satisfy x cubed plus 2x squared minus 5x minus 6 equals 0 are x equals -3, -1, and 2. So on this one, all we have to do is write down our solutions. So it's -3, -1, and 2. And we're done with that one. So if you get the graph and you can see all of the solutions that you're looking for, then you just write it down and that's all you have to do. So example 2 is going to be one where we aren't going to get quite that lucky because you have to know what to do if you can't see all of the zeros on the calculator. So again, on this one, our highest degree is 3. So we're looking for 3 solutions. So the first thing that we're going to do is graph it. And I went ahead and did that on Desmos for us. And the only zero we can actually see is right here at 2, 0. So at x equals 2. So we're going to come over here and we're going to write down our 0 that we know is there. And then we need to use the quadratic, then we're going to do a couple of different things to break this down so that we can find our other 2 zeros. So right now we have the x cubed minus 8. but we know that one of the zeros is 2. So that means we can divide the 2 out and break it down from this cubic function into some quadratic function, and that'll make it easier for us to find the other zeros. So step 2, if you can't see all of the zeros, is going to be use synthetic division to factor. And then in this step, the remainder in synthetic division should always be 0. Because your goal is to break it down to a quadratic expression. So you don't want a remainder in there. So I'm going to set up the synthetic division. And the thing that we're dividing by is just x equals 2. So we're going to put a 2 on the outside. And then I need to write down my coefficients. So I would have like 1x cubed. And then for x squared, we skipped that term, so we have to put a 0 in. For our regular x, we skip that term, so we have to put another 0 in. And then for our constant, we have -8. So now I'm going to do synthetic division on this so that I can break it down from this cubic to a quadratic. So first I'm going to drag down my first coefficient of 1, and I'm going to multiply that by the 2 on the outside and put it in the next column. So 1 times 2 is 2. Now I need to add my column. 0 plus 2 is 2 again. 2 times 2 is 4. 0 plus 4 is still 4. And then 4 times 2 is +8. And -8 plus +8 gives you that remainder of 0. So then you have to go back in and add in your x's. So we started with x cubed and we divided by 1x. So now we're down to x squared plus 2x plus 4. And this is the quadratic that we have now. So then you're going to look at that quadratic expression and you have to find the other 2 roots or the other 2 solutions from this quadratic. And the way that you do that, if you remember from previous math classes, is you can use the quadratic formula, which is this x equals -b plus or minus the square root of b squared minus 4ac all over 2a. And so in this scenario, we have 1x squared plus 2x plus 4. So if you look at the quadratic, if you guys remember, it would be to get your a, b, and c, you have ax squared plus bx plus c. So that means this 1 is going to be our a, this 2 is going to be our b, and the 4 is going to be our c. So we just have to put these numbers into the quadratic formula to finish solving this polynomial. So I'm going to have x equals -b, which is -2, plus or minus the square root of b squared, so 2 squared, minus 4 times a, which is 1, times c, which is 4, and then all divided by 2 times a, which is 1. So then, and this is really important, and I really want you to pay attention to what I'm about to say. Whenever you're typing this into your calculator, don't type the whole thing. You're not going to get an answer that works out perfectly. What I want you to type in first is just the part that's under the square root sign. So 2 squared minus 4 times 1 times 4. So I'm going to go to my calculator. And you may be doing this on a phone or a different calculator, whatever you have. But we have 2 squared minus 4 times 1 times 4. And that's going to give us -12. And then I just want to write the next step using that -12. So now I would have -2 plus or minus the square root of -12 divided by 2 times 1 is just 2. And then we're going to use those concepts that we were doing yesterday of simplifying imaginary roots to simplify the square root of -12. So to do that, I'm going to still have -2 plus or minus, and then I'm going to have the square root of -12. And let me do that over at the top, just separately so that you can see it. So I would have the square root of negative 12, and then that's going to equal the square root of negative 1. And then you start thinking about perfect squares that could be factors of 12. So 12 is going to factor out into 4 times 3, with 4 being your perfect square. So it'd be like the square root of negative 1 times the square root of 4 times the square root of 3. And so then you're going to start simplifying what you can. So the square root of negative 1 is going to be I. The square root of 4 is 2. And then the square root of 3 can't be simplified or reduced, so we stay at 3. So this 2i square roots of 3 is what's going to go here. So we have negative 2 plus or minus 2i square roots of 3, and then divided by 2. And then once you hit this point, the only thing that you can simplify further is if your number in front, your negative b, and then a number in front of the radical, so the 2, and the denominator can be simplified. So what I mean by that is we have this negative 2 and this 2 here. Both of those are going to be divisible by the 2 that we're dividing by. So you can do negative 2 divided by 2 to get negative 1. And then we have plus or minus 2 divided by 2 is just going to be 1. And then you would have I square roots of 3. And then that gets rid of that denominator. If this negative b, the number in front of your square root, and the denominator, if those two numbers are not divisible by the denominator, you're not going to want to do that. But in this case, we could. So the answer in like the simplest form would be the negative 1 plus or minus I square roots of 3. And so then we're going to go back and we have x equals 2. And then our other two solutions, because this represents two separate solutions, are going to be negative 1 plus or minus I square roots of 3. So then just for it to be a little bit neater down here at the bottom, I'm going to rewrite it. So we have x equals 2 and then negative 1 plus or minus I square roots of 3. And then this is your final answer. So then here's our last example, and we have x to the 4th minus x squared minus 72. So since it's x to the 4th, we're going to be looking for 4 solutions to this one. So step 1 is still going to be just to graph it and find the real solutions. So I have my graph here, and I'm going to click on my 2 zeros, which are at negative 3 and positive 3. And then I'm going to come in here and I'll fill out the ones that we know. So negative 3 and positive 3. So then in step 2, since we have x to the 4th and our goal is to break it down to a quadratic, and we have 2 zeros, what we're going to have to do is use synthetic division twice. So we need to divide by both zeros. So the first zero that we divide by, we'll break it down to a cubic equation. And then we need to divide by the other zero on the cubic equation to break it down to a quadratic. So let's try to get that set up. So first I'm going to start with dividing by the negative 3. Sorry for my phone, that keeps going off. So I'm going to start by dividing by the negative 3. So then I'm going to fill in my coefficients. So I have 1x to the 4th. And then x cubed, we're going to have a 0 because it skips that term. For x squared, it's a negative, so I'm going to have a negative 1. We don't have a regular x term, so there's going to be another 0. And then our constant is negative 72. So this is a little bit longer than a lot of the synthetic division that we've done, but it's still going to be the same process. So we're going to drag down that first 1, multiply by the negative 3. 0 plus negative 3 is negative 3. Times negative 3 is 9. And then negative 1 plus 9 is going to be 8. times the negative 3 again is going to be negative 24. 0 plus negative 24 stays as negative 24. And then times negative 3 is going to give us a positive 72, which gives us the remainder of 0 that we want. So then this is where it gets a little bit weird because we divided by the negative 3, but we need to divide by the positive 3 as well. So if I wanted to, I could go back in and put all of my x's in here. And it would be, we started with x to the 4th, we divided by 1x, so it would be like 1x to the 3rd minus 3x squared plus 8x minus 24. You would just be starting with that x to the 3rd power and going down by 1 power of x each time. But since we're going to do synthetic division twice, if I did that, I would really just be taking the coefficients again, which we already have. So what we can do instead is just go ahead and draw another synthetic division box. And this time we're dividing by 3. And we're using the coefficients that are in this row that we already have of 1, negative 3, 8, and negative 24. You don't really have to worry about the remainder column because that was 0. So I'm just going to scratch that out. So now I'm going to drag down my 1 again, multiply by 3, and we have a positive 3 here. Negative 3 plus 3 is 0, times 3 is 0 again. 8 plus 0 is 8. And then 3 times 8 is positive 24. Negative 24 plus positive 24 gives us our remainder of 0. So then now I'm going to go back, and I started with an x to the 4th term. When I divided by the x equals negative 3, then I started with an x to the 3rd term, but I divided by x equals 3, and so now we have 1x squared plus 0x plus 8. So if I wrote that out, it would be x squared plus 8, and we're still setting that equal to 0. So you can use the quadratic formula if you want to, where you would have a equals 1, b, since there's no x term, would be 0, and c would be 8. But whenever you have one of these where we have b equals 0, you can also use the square root method, which is what I'm about to show you. So if we have x squared plus 8 equals 0, and there's no just regular x term, what we can do is just subtract the 8 from both sides, and you would have x squared is equal to negative 8. So then if you have x squared is just equal to some number, you can take the square root of that number, and we would have x equals the square root of negative 8. And then whenever you do a square root in this scenario, don't forget to put your plus or minus out front. And so you would have x equals plus or minus the square root of negative 8. And then we're going to simplify that the same way we were doing things yesterday. So it would be plus or minus the square root of negative 1 times the square root of any perfect square that goes into 8. In this scenario, it's going to be 4 times 2. So it would be the square root of 4 times the square root of 2. And then I'm going to simplify the ones that I can. So the square root of negative 1 is going to be I. The square root of 4 gives us that plus or minus 2. And then the square root of 2 can't be simplified further. So the plus or minus 2i square roots of 2, that's going to give us our other two solutions up here. So we had negative 3, positive 3, and then our other two solutions are plus or minus 2i square roots of 2. And then remember that the plus or minus gives us two separate solutions, so that gives us all 4 solutions right there. So now that went through all 3 of these examples of how to solve. So remember, always graph first. If it's x cubed and you found 1 0, you're going to use synthetic division once. And if it's x to the 4th and you found 2 zeros, then you're going to use synthetic division twice. But if you found all of the zeros that you needed to by graphing, then just write them down. So what you're going to do now is practice with these 6 problems, and that is all for today.